Let's walk through an example of creating a box and whisker plot. Now, the first thing you need to know when creating a box and whisker plot is what is necessary and included in our 5-number summary, because that is what's part of a box and whisker plot. So in our 5-number summary, just like the name suggests, we're going to need 5 things. And those 5 things include the minimum, quartile 1, quartile 2, quartile 3, and the maximum. So right now we're going to start off by solving all of those. So the first thing we should do, because finding quartiles involves finding the median of data multiple times, we're definitely going to need to put it in order. That's going to be our first step. So let's go ahead and order this data. Looks like 26 is going to be the smallest, then 28, then 29, 32, 36, 37, 38, and 40. All right, so we have all of our data set up, and what I want you to remember is that when we're finding quartiles, we're actually finding medians. So our quartile 2 is just going to be the same as finding our median, and then quartile 1 is going to be the median of the lower half of data. Quartile 3 would be the median of the upper half of data, and we'll walk you through that right now. But it's always a good idea to start with quartile 2 since we're just going to find our median first. So let's go ahead and find the values in the middle. So in this case, we have 1, 2, 3, 4, 5, 6, 7, 8 values in our set, which means we're going to have 2 values in the middle, and we're going to have to find the mean of those in order to find our true value that would be in the middle. Okay, so if this is your method, you can X off 1 from each side until you know you end with your middle values. In this case, I find that 32 and 36 are my middle, so I'm going to find the mean of those two. The way I do that is I add both of those values together, and then I divide by 2. Remember, I divide by 2 in this case because I'm only talking about those 2 middle values. And this mean or average is going to give us the number right in between those 2 numbers. That way we know what our median of the whole set is. Okay, so when I add those 2, I'm going to get 68 divided by 2. And then when I divide 68 by 2, I end up with 34. And your last step, which should be checking to make sure if it makes sense logically. Does it make sense that 34 is in between 32 and 36? And yes, it does make sense, so hopefully that would save us from making a simple mistake. All right, so now we are going to divide our data set. Anytime your data set had an even number initially, you're just going to divide it straight in half to find your lower and upper halves of data. If there was an odd number in your set, then you would not include the median, but you would just take the numbers around it on the left side for the lower half and the right side for the upper half. So over here, these 4 values are going to be our lower half. We're going to use those to find our quartile 1. And over here, this is going to be our upper half, and we're going to find those values to find our quartile 3. All right, so quartile 1 is the median of our lower half. So let's find that. We have these 4 values. If you wanted to do the same Xing thing, you can do that. We end up with 28 and 29 in the middle. And we use the same process we just used in finding our median over there. We want to find the number in between those 2, so we have to take the mean of them. We find the mean by taking the sum of the values, so 28 plus 29. And in this case, that is going to give us 37. And then we're going to divide by 2 since we're dividing by how many values in this set. And remember, we're only talking about these 2 values right now, and that's why it is 2. And then when we do that, we are going to get, oops, I'm sorry. I just realized my math is not correct. That is not 37. That should be 57. There we go. And when I do this, I am going to get 28.5. Remember, you can absolutely use your calculator to do that as long as you are setting up your work to correspond with it. All right, so we have our quartile 1, our quartile 2. Now we need our quartile 3. So we're going to use that same process over on the right side for the upper half. So we can X them until we find our 2 in the middle, which are 37 and 38. And remember, we're going to find the mean of those two values, which is found by taking the sum of the values and then dividing by 2. So in this case, when we add those values, we are going to get 75 divided by 2, which is going to give us 37.5. All right, let's ask ourselves if that makes sense logically. Does it make sense that 37.5 is in between 37 and 38? Yes, it does. So we should be good to go. And right now we can check off what we have in our 5-number summary. We have quartile 1, quartile 2, quartile 3, and we need the minimum and the maximum values. Should be very easy to find. So in this case, our minimum value, minimum just means smallest value in the set. Since we already ordered the data, it'll just be the first one to the left. That's 26, and your maximum will be the one to the most right. It's your highest value. In this case, that is 40. So we have everything we need for the box and whisker plot. So let's set up our scale and go ahead and draw that. So here's your box and whisker plot. In this case, our data ranges from 26 to 40. You pick your own scale. So I'm going to pick going by 5s. So I'm going to start with 25. 30, 35, and 40. And if you wanted to, you can draw the little points in between to represent, or we're just estimating, that's fine as well. All right, I'm gonna make this a little bit shorter since I didn't need all that room. And let's go ahead and plot our points. Remember, you're estimating about where they would be. So your smallest value is 26, that would be a little bit past 25, about right here. Next value, quartile 1, is 28.5. That would be almost in the middle, but a little bit more towards 30. Our next value here is 34, which would be really close to 35, just to the left of it. After that, 37.5, so that would almost be in the middle right there. And your max value would be 40, which is just right above that 40 point. And then we do that. And remember, our last step is drawing the boxes for our box and whisker. And remember, I always say to remember that because quartile, and a tile is like a box or a square if you have a tile floor or a tile countertop. So we're going to put the box around our quartiles always. And there is your box and whisker plot. Now, when you're remembering about a box and whisker plot, let's say you were asked to analyze the set. So this set was based on number of photos. So I'm going to go ahead and label just to answer some extra questions about box and whisker. So let's see, our minimum was 26. Our quartile 1 was 28.5. Our quartile 2 or median was 34. 37.5 was our quartile 3, and 40 was our maximum. So what I want you to remember is that each section from dot to dot represents 25% of the data from this set. So each place from dot to dot represents 25% of this set. So if you were ever asked to answer questions about a box and whisker plot, just know that. So let's say the question was something like, what percent of people had 34 or more pictures? So in this case, remember this data is number of photos. And in this case, you would find 34, which right here is at our median. And if they said 34 or more, we would go this way. And we can see that included within that is 125% and another 25%. So we would answer that 50% of people had 34 or more photos. Okay, so if you were asked any questions regarding percents with a box and whisker plot, that is how you would answer it. Let's say you were asked a question about variation. If it said, is there a larger variation below 28.5 or below quartile 1 or above quartile 3, above 37.5? In that case, you would look at both of your whiskers and you would try to find out which side was longer. In this case, they both look pretty close in size. So remember, you can always do the math to support that as well. So you would do 28.5 minus 26, which would get you 2.5. And then you would do 40 minus 37.5. And in that case, that would also get you 2.5. So you would actually find that the variation was even. And that's why we would always do math to support those, because when they look pretty close, you're going to want to support it with mathematics, because remember, graphs can be off by a little bit. Okay, so that's a little bit of information on how to analyze a box and whisker plot as well. Hopefully from this, you know how to create one and analyze it. All right, hope that helped you.